Alright, so we are going to do number 9 through 15 on this video. So there we go, number 9 starts down here. We need to find the exact value, and we're going to go from 0 to 2 pi, not including 2 pi, but including 0, right? So our interval really will be from 0 to 2 pi, open end there. Okay, so we have a cosine inverse of a cosine, and we have to remember a few things. We have to remember that the cosine inverse is defined on negative pi, sorry, that should be on 0 to pi, my apology, on 0 to pi. Okay, so what that is saying is that we're only going to be looking at quadrant 1 and 2 because the cosine function, being an even function, for us to keep it so that we can do, so that the inverse will be a function, right? It has to pass the horizontal line test, if you remember that from your algebra. Then we would have to start here at 0 and go all the way here to pi, because after that our function will start repeating, right? And then we wouldn't pass the horizontal line test anymore. Okay, so that's it. We have just to remember cosine inverse, we're in quadrant 1 and 2 only. So we have a little restriction in our domain here. Then the other thing I noticed right away is that I have a cosine inverse of a cosine. Well, if you don't remember that right away, that those two are inverse of each other and they're undoing each other, that's okay too. You just have to work it out. But you have to remember also that a cosine, let's see, can I put that here? Sorry. A cosine is an even function. Therefore, we know that the cosine of a negative angle is going to also be equal to the cosine of that positive, right? If I pick negative pi, so if I would do this graph here, and I would pick negative pi, I would be at negative 1, just like here for positive pi, right? So the negative angle will be the same y value as the positive of that same angle, because that's an even function. This is why. And knowing that, we know that this here will be just the same as cosine inverse of cosine of pi over 4, because it doesn't matter that we have negative, right, because of the even function fact. And then the cosine inverse of the cosine, those are inverse of each other, so they're undoing each other, so this answer will just be pi over 4. So this was a whole bunch of algebra review. If you don't remember that those two are inverse and they're undoing each other, then you will just do your triangle and think about it this way, or use your unit circle and work it this way. All right. Sine inverse. Now the sine inverse, let's use a different color so that we don't mix them up. So the sine inverse of an angle is going to be restricted, so is defined on the interval, and that will be from negative pi over 2 to positive pi over 2. And really what it is quadrant 1 and quadrant 4. Okay, and again, the reason behind that is because a sine function is an odd function, and therefore if I want to have the inverse to be a function, I need to restrict my domain to just that, so that when I do the horizontal line test, the inverse would actually be a function also, right? So we're restricting from negative pi over 2 to a positive pi over 2, and therefore quadrant 1 for the positive pi over 2, and clockwise to negative pi over 2. Alright, so sine inverse is 1/3. So I'll have to do a little triangle here. So if my sine inverse is 1/3, that's all positive. Therefore, I'm not going to be in quadrant 4, right? Otherwise, it would be a negative 1/3. I know I'm going to be in quadrant 1. So I'm going to build a triangle in quadrant 1. And the sign will be opposite over hypotenuse, so 1/3 right there. And then using the Pythagorean theorem, and please don't ask me anymore, how did you find that 2 square root of 2? Just do your Pythagorean theorem, right? It's your hypotenuse squared minus your leg squared, and then you take the square root of that, right? And then simplify that square root. So that should give you a 2 square root of 2. By now, you should all be able to do that. We've done them plenty. And so you need to look at that sine inverse of 1/3 as being your theta of the tangent, right? The answer to that is an angle, and that's my angle right there. So then I want the tangent of that angle. So what's the tangent of this angle? Well, the tangent will be opposite over adjacent, so therefore 1 over 2 square root of 2, which when you're rationalizing your denominator, you multiply by a square root of 2, bottom numerator and denominator, and so we have square root of 2 over 2 times, that becomes square root of 4, which is a 2, and then that becomes a 4. There we go. This is the one I had a hiccup on Friday because I was trying to finish in a hurry, and then I think I messed up on that one, so you better want to check that out, please. Number 11. We have a sine inverse, so we're in that same scenario, right? Sine inverse, we know we're going to be quadrant 1 or 4. And the sine inverse now is -1/2, so we know by the negative that we're going to be in quadrant 4. That's where the sine is negative. So I'm going to go in quadrant 4, place a triangle in there, and use my ratio that's given to me. And the sine is going to be -1/2, so I'm going to already put my numbers down, 1/2. Hypotenuse is a distance away from 0. It's never negative, therefore my negative goes with the 1, and that makes sense, right? Because the y value in quadrant 4 will be negative. Okay, so we have a -1. And then we need to figure out what this third side is, and again, you're going to use your Pythagorean theorem. That's going to say the hypotenuse squared minus the leg that you have squared, and then take a square root of that, and that will give me a square root of 3 here. And you can go ahead and do that on the side, right? I'm just going to move on here on the video. And so now, again, we have to remember that, let me switch colors a little bit. Sine inverse of something is just going to be an angle. That stands for your angle. This angle right here, right? That, the one I put there. And so I want the secant of that angle. Well, secant we know is 1 over cosine. So that's going to be a hypotenuse over the adjacent. So that will be 2 over square root of 3. And again, we have a radical in the denominator. So we're going to rationalize 2 square root of 3 over 3 will be your answer. For number 12, my inverse now is outside there, right? So here, this is not an angle. I have actually to find, my angle is given to me, and I have to find the ratio of sides here. So the ratio of side here is going to be sine of 7 pi over 6. So I'm going to go to my unit circle, and I'm going to ask myself, where is 7 pi over 6? So we have 1 pi over 6, 2, 3, 4, 5, 6, 7 right there, right? So that's where 7 pi over 6 is. And the ordered pairs here would be the symmetry of the one we have right there, right? So that would be 1/2 for the y, square root of 3 over 2 for the x, but we have to consider that we're in quadrant 3, therefore x and y are both negative. So this is what I have, and I want the sine of that. So the sine will be the y value, so this here is going to go to a -1/2, right, that whole thing. So really what I have now is a cosine inverse of -1/2. And the cosine inverse of -1/2 is asking me what is the angle that has a cosine of -1/2. So think about your unit circle, and remember cosine you can only be in quadrant 1 and, let's see, quadrant 1 and 2. So we have to make sure that we're going to be there. And so quadrant 1 and 2, I'm going to kind of draw that there. Quadrant 1, quadrant 2. I want my cosine to be negative 1/2, so the cosine is going to be negative 1/2 right here, because this is where my ordered pair are going to be negative 1/2 square root of 3/2. And that angle here would be 2 pi over 3. So that's equal to 2 pi over 3. If I'm going too fast, right, it's a video now, so you can stop me, rewind me, re-listen, right? Number 13. On this one, we are given, you should recognize this as one of your sum formula. And I'm saying sum because I see the plus here, but you have to consider what do we have. So we have a cosine, cosine, sine, sine. So when you have the cosine, cosine, you know that's going to be a cosine of something, and the cosine, the angle between the sine or the operation between the angle will be opposite of what you see here. So I need a minus, and then pick your two angles, right? So 80 minus 20, and then that is the cosine of 80 minus 20 is 60. Now don't stop here, right? Now what you have to tell me what is the cosine of 60, and for that you're going to use your unit circle, and the cosine of 60 is right there in quadrant 1, and that's where the cosine is 1/2, right, the x value. So cosine of 60 is positive 1/2. Alright, so I think on that video in the title I said I'm going to go all the way to number 15, so 2 more to go, and then we're going to stop this video. Now I want the tangent of 105, and 105 is not a nice number on the unit circle, so I have to figure a way to break that into two angles that would either add up to 105 or subtract to 105. And really it doesn't matter what you decide as long as the angles you pick are actually going to be on your unit circle, right? So I have tangent of 150 minus 45. This is what I pick because 150 minus 45 indeed gives me 105, right? So I have a tangent and I'm subtracting. So then it's just a matter of using your formula, right? So tangent of the first angle. I have a minus here, so subtract first tangent of my second angle, which is 45, all over, I probably should put degrees here because those are all degrees, over 1. When I subtract here, then down here I have a plus, right? And then the two tangents from my numerator, but multiplied with each other as opposed to added or subtracted. There we go. That's how we set up the formula. Now it's just a matter of finding those values, right? So we're going to use our unit circle. And I need two angles. I need 150 and 45. So the 150 will be right there, right? 30 degrees before 180. So that's this one. And for this one, I'm going to have positive 1/2, but a negative square root of 3/2. And then my 45, well, that's a nice one because those are the same coordinates, right, for x and y, and we're in quadrant 1, so they're both positive. But now I need to know what the tangent of that is, right? So we have to recall that tangent of 150 is going to be equal to the y divided by the x. So y divided by x is the same thing as multiplying by the reciprocal of x, and I need that negative. And so the 2's will cancel, but not the negative, right? So I have a negative 1 over square root of 3, which is going to give me a negative square root of 3/3 once you rationalize. So that's for my tangent, right? That's not my final answer. I shouldn't have framed it. But it's my tangent, and I need tangents here. The tangent of 45, well, that's kind of a cool one, right? Because the tangent of 45, we know, is just going to be equal to 1. Okay, now let's fill in our formula. So what is that? Tangent of 150, we said is negative square root of 3/3. Minus tangent of 45, we said was 1, over 1 plus negative square root of 3/3. I have a negative here, so I'm going to put that in parentheses. And then tangent of 45, which we just said was 1. And if you're looking at what we have here, we have to simplify that big old mess. But I already noticed I have an over 3 and an over 3. So kind of like as a shortcut, I'm going to multiply the numerator by 3 and the denominator by 3. So by doing that, multiply by 3, multiply by 3. So negative square root of 3 over 3 times 3 will just give me a negative square root of 3. And then negative 1 times 3 will just give me negative 3. And notice how that 3 cancelled, right? And the same here, we're going to have a 3 times 1, which is just going to be 3. And then we're going to have, this is 1 times this ratio, so that's just the ratio, and then times 3, those 3 will just cancel, and we will be left with just negative square root of 3. At this point, we need to rationalize the denominator. I can hear some of you say, slow down, Mrs. Williams. Well, stop me, right? Put me on pause until you catch up. Okay, conjugate is what we need, right? We need to multiply by the conjugate of the denominator to rationalize. So that means to get rid of that square root, right? That irrational number there. So the conjugate will be 3 plus the square root of 3, right? Conjugate of that. And then the top we multiply by the same thing, because we have to multiply by a well-chosen one, right? Whatever we put here, it has to be over itself, so that it's a multiplication by 1, so that it doesn't change what we used to have, right? Okay? So then, I guess I'm going here now. Now we are just going to multiply that through, right? So that's just going to be distribute. So negative square root of 3 times 3 is a negative 3 square root of 3. Negative square root of 3 times the square root of 3 is just a negative 3. The square root will cancel. Negative 3 times 3 is a negative 9. Negative 3 times square root of 3 is just a negative 3 square root of 3. Okay? All over. And those are conjugates, so we like that, right? Because when you multiply conjugates, you need to recall that a plus b times a minus b is equal to take the first one and square it, minus take the second one and square it, right? That's what conjugates do. So I'm going to say take the first one and square it, which is 9, minus take the second one and square it, that will just be a 3. And now we need to simplify. So we have negative square root of 3, negative square root of 3. That's negative 6 square root of 3, right? Negative 3, negative 3. How many together? You have negative 6 of them. And that's a negative 12. And all of that is over 9 minus 3, which is 6. And now I can divide every term I have by 6, right? So I have a negative square root of 3 minus 2 over 1. I don't need that over 1, so actually I'm going to make that my answer. There we go. Alright, one more to go and then we stop this video. So here I need the sine of 5 pi over 8. Well, I need to first wonder where would that be. So if I divide the pi by 8, so here is 0, here is pi, and you divide that section, quadrant 1 and 2, into 8 equal parts. That's what that means, right? So that would be, here is 4 equal parts. And here will be 8 equal parts, right? So if you have 5 of them, in what quadrant will you be? Well, 1, 2, 3, 4, 5, you'll be right there, right? So that will be in quadrant 2. So we are in quadrant 2. Why was that important? Because I needed to know, is it going to be positive? Is it going to be negative? What quadrant I am in? So therefore, we're going to say the sine of theta is going to be greater than 0. Now, I don't know what that is, so I'm going to use one of my half angle formulas. So I'm going to say sine of 5 pi over 8 is the same thing as sine of, multiply that by 2, so multiply by 2, I'm going to do it in 2 steps here, just so you can really see. So multiply 5 by 2 is 10 over 8, right? And then, because I multiplied the numerator by 2, I need to divide by 2. And by doing that, I'm creating my half angle formula. And I like that because now I can use this half angle formula. So the half angle formula is going to be equal to, now let's simplify that. Let's do that first. So now that I did this, 5 pi over 8 is going to be the same thing as 5 pi over 4, and then my half, right, to keep that. So here it's just simplifying this fraction. And now let's put it in the formula. So yeah, I'm in quadrant 2, sine is going to be greater than 0, then I don't need the minus for my square root, it's just going to be a positive. And the sine has the subtraction here, sine of whatever it is we have above the half in the half angle, right? So that would be 5 pi over 4, and then all of that over 2. Okay, well, we like that because we do know what 5 pi over 4 is, right? Where is 5 pi over 4 in your unit circle? Five pi over 4 will be right there, right? Oops, I missed it. In quadrant 3, and so that will give you a sign that's negative here, right? For the 5 pi over 4. 5 pi over 4 is here, so the sign will be a negative. So we're going to say, okay, that's going to be equal to square root of 1. I have the minus here, and then that's negative, so it becomes plus, right? I hope you're with me here. I hope you're paying attention. The subtraction, and then the negative sign here, because this here will be negative square root of 2 over 2, right? For the sign, negative. So negative, negative will give me a positive here, and then over 2. And now I just need to simplify that, so I hope by now you're comfortable with me just saying, hey, let's just multiply numerator and denominator by 2. But I multiply that whole numerator, right? So distribute that 2. So 2 times 1 is 2. And then, sorry, that has to be done inside the square root, right? That's kind of important. I need to make that sure that square root is long enough to show that's inside the square root. So multiply by 2 is 2. Multiply by 2, we'll just cancel that 2, and I have a square root of 2 left. And then multiply that by 2 will be over 4, and then, of course, we are still in that square root. But in the numerator, I have a square root of 4, which I know I can simplify. However, my numerator does not simplify any further. So this will be my final answer. Okay, I'm going to stop this video here. Let's see if I can stop it. I lost my mouse.